us to be here today. We give you praise, we give you all the honor, take all the glory, Lord, in Jesus' mighty name. Amen. Hi, good morning, everyone, and sorry for starting the class a bit late. But yesterday, Vicky, can you mute, please? Okay. So yesterday we ended at the point where we said we're going to continue today by looking at the DevOps practices. So yesterday we began by establishing that DevOps in itself is not a job title. DevOps is not tools, but however, that tools are necessary for implementing DevOps. Just like, for example, cooking is not tools. Cooking is a practice. However, we need tools in the kitchen to cook successfully. So we start today. Let's start by looking at some of the practices of DevOps. What is it that we are going to be studying as part of this program? What do DevOps engineers do? Of course, everything about DevOps revolves around one thing: automation. The ability to build system automations for your organization and also for your application. Because think about this, right? The goal is we want to be able to deploy features as many times as possible. And even when it becomes an emergency release, we want to be able to release that feature as soon as possible. We also want to be able to, to ease and, in fact, to ease developers' workflow. We want our developers to have a smooth build system. So what then is build automation? So build automation is one of the implementations that DevOps is supposed to implement as a practice. In the course of implementing this particular practice, we are going to use tools. What then are the tools that we are going to be studying or that we are going to use to implement build automation? So this is the very first time that you'll be hearing about build server. Now, if we go back to your class schedule, see this year, right? This is what? Application build. Application software build, testing, and deployment. So right here, we are going to study a tool called Maven, Apache Maven. So depending on the language of the application, so the tools are chosen based on what? Based on the language of the application. Okay. So for example, if the application is a Java-based application, right, the build tool can either be Ant or Gradle. If the application is, a Python application, we have PyBuild. If the application is going to be a Microsoft application, in most cases it's .NET, then of course what? We're going to use Microsoft Build. But build automation is one of the practices that as DevOps engineers, we are going to be required to implement for our organization. So when you get hired, the expectation of the company is that you are going to help them to implement build automation. So build automation is part of what we call CI/CD, but let's discuss what it's all about. Automation of the process of preparing code for deployment to a live environment. So first we are going to have code, but who is writing this code is developers, like we saw yesterday or as we discussed yesterday. So developers will make sure that our application code is available. Then DevOps will need to set up a build system where developers can easily do their builds, okay, and the process continues. No, 1 second. Let me join from this other machine. Okay. And that process is going to continue. So depending on what language I use, code needs to be compiled, linted, mimified, transformed, and unit tested. So like I mentioned yesterday, working as a DevOps engineer, everything happens in the team. As developers get the codes available, we need to transform that code into a package. So when we get to studying build automations and build systems, you will realize that we will take a chunk of code that developers have written, right? In most cases, about 1,000 lines of code or more. Then we are going to package it. So in that case, we need a build tool to package that application. So build automation is one of the practices that you are going to be expected to implement as a DevOps engineer. That's just one. That's what we mentioned that we'll be looking at the culture, the practices, and the tools. So what tools will then be needed to implement build automation? That's the question, right? So build automation means taking these steps and doing them in a consistent, automated way using a script or tool. However, we are going to use tools for the build. The tools of build automation often differ depending on what programming languages are and frameworks are used, but they have one thing in common. The one thing in common is automation. As a matter of fact, all of your password as a DevOps engineer is going to be automation. Oh, I have the ability to automate processes for my business. Okay, for what? For my company. Before I came in, everything was being done manually. But now, with my knowledge as a DevOps engineer, I've been able to set up a build automation system for our developers. Such a way that when they commit their code, the CI server triggers the build. Okay? So usually build automation looks like running a command line tool that builds code using config files, scripts that are as part of the source code. So source code is what developers are going to develop. Build automation is what is independent of an IDE. What does IDE stand for? IDE stands for Integrated Development Environment. Okay? Even if you can build within the IDE, it should be able to work the same way outside of the IDE. As much as possible, build automation should be agnostic of the configuration of the machine that it is built on. Your code should be able to build on someone else's machine the same way it builds on yours. So this is mostly for developers. Newsflash, we don't have any business whether the code builds well or it builds well. But what we want to be able to achieve as DevOps engineers, as individuals who want to implement the DevOps practice of build automation, is that we want to make sure that this code is agnostic in the sense that it can build on any system. Okay? What are the advantages? The first advantage is fast. Automation handles tasks that would otherwise need to be done manually. So this is the way automation works. Okay. If we set up an automation system, everything is linked to what we call a source code. So the build is triggered each time there is a change in the source code. It automatically builds for you. So as opposed to having to do it manually, nope. So because we have a build server in place, what happens now is that we are going to have a consistent way of build. So build are going to happen the same way each time there is a build. Repeatable. The process can be done multiple times with the same result. Any version of the source can always be transformed into a deployable code in a consistent way. Portable. Portability means that the The code can build on your machine just like it's going to build on, on Adiolo machine, Vicky's machine, or Ama's machine. Okay, reliable. There will be fewer problems caused by bad builds. Why? Because we have a system in place. Okay. So the second thing that we want to be able to implement is what they call continuous integration. So now, if you look at your job description, if you look at majority of DevOps job description, you'll see what? You'll see the ability to implement CI/CD. CI/CD stands for continuous integration and continuous deployment. Today, you cannot be hired for any company with an inability to implement continuous integration and continuous deployment. Okay? Continuous integration is, everything that happens before the application is deployed. Continuous deployment is everything that happens after the application is built, tested, and stored. Then, of course, what we have to deploy. Okay? So the practice of what? Frequently merging code changes done by developers. See that? So again, who is going to set up the system? DevOps. Okay, it's our job, it's our business to set up this continuous integration system so that our developers can easily what? Run their code without any issues. So traditionally, the developers work separately, perhaps for weeks at a time, and then merge all of their work together at the end in one large effort. But continuous integration means what? Constantly throughout the day, usually with the execution of automated tests to detect what any problems caused by the merge. Now, in the traditional approach before DevOps, developers assume, okay, we are working on an application, and our developers have to develop the payment system of that application, the user account system, and probably the authentication system. Those are what? Those are three features: users, authentication, and the payment systems. Let's add products or catalog, right? So we have these four systems. Previously, developers will have an option to sit down and what? Deploy and develop all of these four features all together before deploying it. But when we come in as DevOps engineers, we want to be able to encourage what? We want to be able to encourage the practice of what? Deploying small codes. You understand? What? Deploy as soon as you have something to deploy it. Let's not wait until all the four features are available. So DevOps comes to make sure that developers are able to deploy this work as often as possible in order, to avoid, to avoid problems. Because if we have to deploy everything at once, what if it breaks? How are we going to eliminate the problem, right? But if you deploy the payment feature and observe it, okay, it's working very well. Then what? We deploy the user management system, or it's working excellently well, it's working. Then what? We can as well deploy the other features. Now, if you deploy a feature and it breaks the application, we know exactly what is breaking the application. Why? Because prior to that deployment, everything was working well. But now, the application is down or is broken. So what? We can easily roll back. So what does CI/CD or CI looks like? Continuous integration is done what? With the help of a CI server. Interview question: what CI server have you used in your project? See that this is why it's so easy, I would say super easy, to land a job as a DevOps engineer. Because these CI servers, there are so many there in the market. All you have to do is to learn one or maximum two. Like have a very good experience with one, and maybe knowledge of the others. So it's like, for example, I drive a Honda Civic car. So I have what? I have super, in fact, strong experience with with my Honda Civic car. Doesn't mean that I don't know about EV, even though I've not driven EV though, electric vehicles, but I have seen others drive it, so I have experience with it, right? So when a developer commits a code change, the CI server sees the change and automatically performs a build, also executing automated tests. So automated testing is also part of the process. So automated tests is often done with technologies such as JMeter. So JMeter is a tool that is used to often perform automated tests. So you hear of tests like load testing, okay, performance testing, functional test, integration test, okay. These are all tests that we need to run on the application before it hits the market, right? Just like if you run a restaurant, you won't take the risks of taking your stuff to the market or to your customers without testing it, because that is going to ruin your reputation. People are going to avoid your products. So the same thing happens. Nobody wants to, take that risk. It's too big a risk that nobody wants to take. So with CI, we realize that code commits can be done multiple times a day, and the same process runs. So when we get to here, right? So this is the area where we are going to study CI/CD. It's right here, Jenkins and Azure DevOps. It's called what? It covers CI, CI/CD, continuous integration, and continuous deployment. Okay. So if there's any problem with the build, the CI server automatically and immediately notifies the developers. That's also what we want to be able to achieve, automatic notification. So I'll tell you what happens at HP, where we have built system that, we connect the system to another system, that when something goes wrong, let's say a build is failing, all the developers get text messages on their phones. Your build is failing. If a system is not working as expected, everybody is informed. That's why, as part of your job, you may work for a company and all you do is to monitor and report. Okay, monitor and report. That's why we are going to look at how to implement monitoring system. If anyone commits code that break the build, they are responsible for fixing the problem or rolling back their changes immediately so that other developers can continue working. So yes, it's possible that a developer can commit a code that breaks the build. This of course is going to hold the system. That's why the company needs DevOps engineers that can easily, ask the developer to roll back. Or of course, we can roll back on their behalf. So this is done through what we call on commit. So the same way you commit, you can on commit. So like, for example, you know what? Okay, it's like, okay, I send a message to a WhatsApp group. I say, oh, this is not the right message. So what can I do? I can delete the message, right? You can then delete the message. All right. So why do it, in fact, why should you bother about continuous integration? Again, this is automation. Okay, it's all automation. So the first level is that it helps us to detect bugs early. If code doesn't compile or an automated test fails, the developers are notified and can fix it immediately. The sooner these bugs are detected, the earlier they are fixed, right? The earlier they are fixed. So think of it this way. You have a restaurant and you are wise enough to bring in a tester or to just employ a kitchen staff whose job is to test. So as you're preparing that stew, or that moi moi, or maybe that arrow, or that Niger jollof, right? So that's okay, discover that, oh, you know what, salt is becoming a little bit much. And so he asked you, there's too much salt in this rice as it is right now. You know, what can we do? Okay? Because it is early in the process. You know what I'm saying? We can what? We can easily discard that particular pot of rice and cook a new one. Right? But we don't want to get to that level where we want to discard. That's why we want to what? We want to make sure that we have the right measurements of ingredients running through the system. We are able to detect the bugs. So too much salt is what is an example of a bug, okay, in that particular preparation. So a bug is anything that can break the flow or the smooth functioning of an application. It's a bug. Again, what? This then leads to what? No, we can what? We can eliminate the scramble to integrate just before a big release. The code is what is constantly merged, so there is no need to what to do a big merge at the end. So here's an example of what? Of frequent change. Let's say, for example, you were supposed to write payment methods, okay? But the developers are releasing payment method, okay? Now we want them to add an S. It's a mistake that we don't want to be on the front end to our customers. So if the developer goes in and add that S, they can what? They can easily, right, commit the code again. It's just one change, but that is going to build and correct the error in the front end. Again, what? CI, continuous integration, makes what? Frequent releases possible. So code is always in a state that can be deployed to production. So now we are going to study the different types of environment when it comes to application. So as we set up build automation systems and CI systems, there are different environments that we want to deploy the application in. We rarely never deploy our applications directly in production. So application must first be deployed in development environment. The development environment is owned by developers. That's the environment. Then, of course, we have the testers environment. This is the most important environment. And often, developers and testers are not always friends. Because think of it like this, okay? You work in a kitchen and you are the tester. How do you think the cook is going to feel? Say, oh, you know what, there's too much water in this soup. Right? Of course, right? He or she would feel better. Okay? Or say, oh, you know what, there's too much salt. No, the oil mixture is not done right. So we cannot what? We cannot serve this meal. Let's fix it. Okay? Automatically, there will not be a good relationship between that kitchen staff and the tester. Why? Because you know what? Testers are supposed to put, are supposed to put developers on their nails or on their heels, right? So they are always on the watch. So think of a tester like an inspector. Do you know that if you are building a house, okay, and you have an inspector who comes around to check the design and the foundation, let's say it's supposed to be a 20-story, right? And you are already at the second story. An inspector can come and say, oh, no, what? No. We cannot continue. All right? This building is not going to stand. That rod over there, or that pillar, is the main pillar, and it wasn't done right. Now, let's take a pause. How do you think the the civil engineer is going to feel? In fact, how do you think that the workers are going to feel? Those who have put in the effort to bring the house to the first floor, like to build to the point where, in fact, they're done with the foundation. But now an inspector comes in and say, "Oh, you know what? We cannot proceed. I cannot sign off for the story, for the third story building." Why? Because the materials I see here is not right. So we have to put a hold on the project and redo it. So now imagine what the process of correcting that error is devastating, right? So that is why testers always have issues with what? With developers. Because a tester will tell a developer, "Oh no, okay, the integration test is not working well. Please, did you write these test cases?" Okay. A tester is also referred to as a QA engineer. Okay. A quality assurance engineer that makes sure that what? That quality of the application is maintained at all times. Okay. Good. So makes what? Continuous testing possible. Since the code can always be run, QA testers can get their hands on it all throughout the what? The development process, not just at the end. So instead of us to wait until the building is already at the first level, can the inspector start giving us feedback at the foundation level? So a wise thing to do is, you know what? Once we put the pillars, we call the inspector. Oh yeah, come and check. Right? Are these pillars the right pillars? Have we done the right job? Or even what? Before even planting the pillar, we consult, okay, the inspector. What do you suggest? What do you recommend? So what? You get his input at that early hours, and everything goes well. Why? Because he's going to, oh, you know what? Let's use a rod of this category. One of these rods is about $10,000. Buy these rods. They will work, right? Now that system works. Understand? That's going to work. Okay, now let me ask, does anyone has a question so far with what we are explaining? So what we are laying down the foundation of what we are going to be studying as part of our program. Okay. So one of the benefits also is that it encourages what? Good coding practice. So frequent commit encourages what? Simple modular code. So things become so easy. Why? Because we don't have to code the entire application before we build, before we test, and before we deploy, right? We can deploy, simple, code. So maybe it is just 10 lines, let's deploy it. 5 lines, let's deploy it and see the impact. And if something was to break the application because of those 10 lines, it's easy. We can roll back. The third practice is continuous delivery and continuous deployment. Yes, and now let me tell you something, okay? You can work for a company and all you do is what? Is to implement continuous, okay, delivery and continuous integration. So if you put 1 and 1 together, 2 and 3 together is what? It gives what we call continuous integration and continuous delivery or deployment. Now, what is the difference? So of course, we are going to look at this when we get to what? When we get to the concept of, automation. So how do you set up a CI/CD environment? So continuous delivery is what? The process of continuously maintaining code in a deployable state. So regardless of whether or not the decision is made to deploy, the code is what? Is always available in the state that is able to be deployed. Okay. Now, the only difference between continuous delivery and continuous deployment is that For delivery, there's a manual approval before what they release to the market. So it's like, for example, okay, I'm the owner of a bakery, but what I give an order. Before you move the bread from the store to our customers, I must inspect it. Or I have employed somebody who must sign off before the bread goes out, before our product goes out. So in that case, yes, the bread is available for delivery to our customers, but what? Maybe we are waiting on the store manager to come and count, maybe count and do, I know what I'm saying, and get everything ready for delivery. So this is what continuous delivery means, and that's how it differs from continuous deployment. So an interview question around this area is, what is the difference between continuous delivery and continuous deployment? Of course, we are going to, examine this, as we progress. So what this is covered on at chapter 4, right? That's what we are going to cover continuous delivery and continuous deployment. It's a very, very interesting concept. Okay. So what? Continuous deployment is what? The practice of frequently deploying small code changes to production. Now, what is production? Think of production like finally serving that meal to your customers. Okay. The bread leaves the oven and it goes to the store straight over, and it goes to a sales point where your customers are already waiting in line to get your bread or to buy the bread. That is continuous deployment. So continuous delivery is keeping the code in a deployable state. Continuous deployment is actually doing the deployment frequently. So in most organizations, in mine, for example, we always schedule a day for deployment. Okay, so even though we can deploy at any time, we don't just deploy without getting permission from the business. Okay, so with continuous deployment, deployments to production are routine and commonplace. They're not a one big scary event. So what does steady continuous deployment and continuous delivery looks like? Each version of the code goes through a series of stages, such as automated build, automated testing, and manual acceptance testing. The result of this process is an artifact or package that is able to be deployed. Of course, when we build, we have an artifact. So think of it this way. When you mix the flour and everything that you want to do that bread, what happens? You now have a bread, right? That bread is an artifact of the ingredients that you have put in. That becomes an artifact. But of course, when you have that sample bread, what do? Then what? We want to be able to, to test it. But again, all of this should go through automated tests. However, there's what we call manual acceptance testing. Now think of it this way. Will you go buy a car, maybe an EV car, that have not, in fact, without first of all testing it? I don't think so, right? That's why when you go to the car dealer to buy a car, what happens? They hand you over the key. Oh yeah, come on, you go and test the car, right? And this is why most of these our social media influencers are really deceiving us sometimes, right? Because somebody can walk to a car dealer and like you can test a car for more than an hour. Understand? You can drive for as long as you want to go in some places or some dealers, right? So during that period, they go stand somewhere, they take pictures. Oh man, I just bought my new, Toyota Highlander 2025. Hey, that's how people say, wow, congratulations. I just putting you under pressure for nothing, right? That's a car. It's a car he or she is just testing, right? It's a car that is being tested. So because of that, what happens? You start saying, "Oh wow, God is really blessing this man," not knowing that. Okay, you know, it's just like I was speaking to a friend of mine who's in America. Okay, and he told me that. So I was like, "Oh man, I mean, I think you're doing so well, bro. I see you post cards on Facebook like every second, and in fact every week and all of that." I say, Mr. Elvis, don't worry, it's packaging. I was like, I laughed until I said, it's packaging. Like seriously, right? So it happens, okay? So what manual testing is different from automated test. Why? Now think of it this way. How will you want to test your payment system, for example, right? Would it better go through automated test or manual test? Manual acceptance testing is the right approach to go. So even though, yes, we want to be able to implement automation and everything, but what? We are going to take a pulse here. So this is where our QA are actually going to what? Go test if that payment method is working. So they'll put in what? A fake credit card number and see if the transaction is going to go through and whether the money get deposited in the account. That's part of manual testing. Just an example, right? Of course, if a deployment, okay, when the decision is made to deploy, the deployment is automated. Yes, always automate your deployments. All right, always. So we, as DevOps engineers, right? As DevOps engineers, we always automate our deployment. If a deployment causes a problem, it is quickly and reliably rolled back using what? An automated process, hopefully before a customer even notices the problem. So think of it this way. We are using the WhatsApp application for our businesses and communications and social interactions. Now, WhatsApp wants to deploy a parental control feature. Okay. They implement that deployment and then bam, the audio feature on the application, on the WhatsApp application, stops working. Okay. So now they can automatically feel it in the testing environment. Why? Because there's that testing. Oh, this is not working. And so we cannot what? We cannot push it to production. Okay. So rollbacks aren't really a big deal because the developers can what? Can redeploy a fixed version as soon as possible or what? As soon as they have one available. No one grips their decks in fear during a deployment, even if what the deployment causes a problem. When we have the continuous deployment process in place. Okay. When we have that, nobody's afraid of anything. Why? Because we can easily roll back. You understand? So I remember there was a day in HP that we did a deployment, and truly speaking, it breaks. Like it broke the application. So when I say it breaks, right, it doesn't mean that the application is not available. No, it's that an application that was very okay with about let's say 100 gigabyte of memory. Now what? Now needs 500 gigabyte of memory to run. Right? It's running so slow. And when you look at the logs from the monitoring perspective, it is not as though we have 1,000 users on the application. That is not the case. So what then is causing our memory consumption to increase or to spike. So spike is the right word. Okay, I'm noticing that after this deployment, there's a spike in memory consumption. Oops, not good. Then what? We have to undo it immediately. Draw what? A rollback. So in most companies, they have a system where you can just click to roll back. Okay, it's often a click or what? You run one command. So for example, you can if you are doing it in Kubernetes, is what you use ham, we can easily roll back. Okay, or uninstall that particular release. So what are some of the advantages of implementing, continuous deployment and continuous delivery? First, what? We can deliver our application faster to the market. We have fewer problems caused by the deployment process, lower risks, reliable rollback, and what? Fearless deployment. I just explained all of that. 4, configuration management. Again, is what? This is a practice. So let me explain the way you're going to understand, right? Now, this has to do with infrastructure. Okay. See infrastructure as the pots in your kitchen. Okay. Without the pot or the pots, okay, you cannot even cook a meal. So yes, you really want to cook this particular meal, but what? You need pots, you need a spoon, in fact, you need plates to serve. In fact, you know what? You need what? You need infrastructure. So in this particular aspect, this alone can give you a job. And we're going to look at the tools that is used for what? For configuration management, right? So config management, what? Maintaining the what? And changing the state of a piece of infrastructure in a consistent, maintainable, and what? And stable way. Changes always need to happen. Configuration is about what? Doing them in a maintainable way. Configuration management allows us to minimize configuration drift, the small change that accumulates over time and makes what difference from one, another, and harder to what to manage. So now this is what happens, okay? Imagine that you work for a company like Netflix. Okay. Netflix has somewhere over 50,000 computers. That is supporting their infrastructure. Okay. Now I want you to think big. So for the over 2 billion Netflix users, okay, to log onto the application and watch their movies, Netflix needs what? That amount of servers to host the application to make it available. Now, bam. This server needs to be maintained. An example of maintenance there is patched, what we call to patch the server, to secure the server. What if we want to deploy security, features on these servers? Okay. It's 50,000 of them. Now, can we automate this entire process, or is it feasible for an engineer to log into the servers one at a time and run security updates? The answer is it is not feasible. So one of the other practice of that is what is to be able to implement configuration management, okay, in an automated manner. So right here, what are we going to study here? See this here? This is what? This is our, see that? Config what? Configuration management, Ansible. So this is what we are going to study. Okay, I'm just preparing the ground. Okay. All right. Makes sense. Okay. So of course, changes always need to happen. Okay. And when the config happens, Okay, it's about what? Doing them in a maintainable way. So what does configuration management looks like? Okay, hey, it's an example. Okay, you need to upgrade a software package on a bunch of servers, like what I just explained, right? Without a good config management, you log into each server and perform the upgrade. However, this can lead to a lot of problems. Perhaps one server was missed due to what? Due to poor documentation. It's possible. Or perhaps something doesn't work while the versions are temporarily mismatched between servers, causing what? A lot of downtime while you do the upgrade. So now think of it this way, right? All of the infrastructure in your kitchen is what? Can you list some of the things you use frequently in your kitchen as you log into the kitchen to maybe to cook, right? A good example is what is your oven, right? The oven. So imagine that you have about 50 ovens in your restaurant that you must maintain. And then you have just about 2 workers. They have it in their manual that they must run cleaning of this oven, every 2 hours before it's being used to heat food or whatever. But now the question that becomes, is it possible to automate that process of cleaning the oven? Is there something that can be installed in the oven that automatically cleans the oven, and sucks away the scent of the foods? Like each time a food is heated, is it possible? The answer is yes. So imagine now, okay, you have a task to upgrade, okay, a software package on a bunch of servers. This is a very good example. Let's say you have 1,000 of the servers, and it's a very, very important upgrade. Now, let me ask a question. How many of you have logged into a bank on the weekend on their app and say, oh, you know what, this app will be unavailable between 4 a.m. So that's what I've seen with banks, okay? Banks always do their upgrades Saturday breaking Sunday, right? So you log and say, oh, you know what, this particular feature, maybe international payments, will be unavailable between 11 p.m. to 4 a.m. Due to what? Due to systems upgrade. How many of you have noticed that? So that is an example of of a configuration management in progress, right? But what if that upgrade needed to happen during working hours? Maybe because it is so important. Maybe our system is being attacked. Can we wait until weekend to do the upgrade? The answer is no. Now, can we deploy this upgrade without affecting or without having a downtime? The answer is yes. Okay. So one of the things that we are going to deploy, okay, as part of our job or to set up is an automated config management system for our organization. That's going to be our responsibility. I will not be surprised that after this class, you can you can already develop your resume and put it out there, and you will start seeing how company will start reaching out to you. They want to interview you, but you know what? It's too early. Okay. So with good config management, you define the new version of the software package in the config file or tool, and automatically roll out the change to all of the servers. So config management is so we have so you are going to study on 2 aspects. All right. The first aspect is is the application. The second aspect is the infrastructure that hosts the application. That's why we start this program with Linux. Okay. So Linux is an example of a server. So we'll come back tomorrow. We'll start looking at how can we work on Linux servers? Okay, not tomorrow. Maybe tomorrow we are going to start looking at how to set up. Okay. how to set up our Linux server, because what? That's an example of infrastructure. Because of course, the application is, okay, infrastructure to run on. Let me ask you a very simple question. Can you run your WhatsApp application without your phone? In fact, can you use WhatsApp without a phone? Is it possible? The answer is, it is not possible. Right? It is not possible to run WhatsApp without a phone. It is not possible. Okay? It's not possible. So what? That's why we start with what? We start with Linux. Okay? As what? As infrastructure. Why? Because this is one of the infrastructure that organizations uses to host the application. Right? Okay. So configuration management is what is about managing your configuration somewhere outside of the servers themselves. Yes. So let me also ask you guys a question. How often do you notice that Microsoft, of course, not Microsoft, maybe, the engineers at Microsoft what have sent updates on your system asking you to restart your computer to update your Windows? How many of you have noticed that? How many of you? Or all of a sudden, what? You get a message on your phone that says, oh, you know what? Your phone is due for an update. And then what? The phone automatically restart. How many of you have noticed that? Now, if you drive an EV car, okay, what? All EV cars are what? Are managed by softwares. In fact, all modern cars actually, like in fact, almost all modern cars from 2021 have applications. How many of you have also noticed that? That all modern cars have applications that control the car. There are cars that if you park the car here in Canada and travel to Nigeria and somebody was trying to break the car, it automatically alerts your phone. Okay, turn on the camera on your phone while you can see what is happening and you can speak. Say, hey, please stop that. You are being watched. Right? And the guy will run away. There are cars like that. Okay, I've seen that also with what? With EV cars. Right? NASA, have you driven an EV car before? Like electric vehicle before? Right? It's a very cool vehicle. It has a lot of, in fact, that is no, it's like if you enter an EV car, it has a computer screen. Everything is controlled by what? By softwares. A friend of mine was telling me that, oh, you know what? If you're driving from the US to Canada and you want a full package for automated driving, what? Just buy it. Just add the feature. The car can drive you without what? Without you touching the steering automatically. Okay? From the US to Canada. Straight up. It will stop where it's supposed to stop. And what? It will maintain the speed limit where it's supposed to maintain the speed limit. In fact, it drives just like as if what somebody is driving it. I say, okay, me, I'm not sure I can ever. Okay, I can never take that type of risks. You understand? It's possible. So now, the point I am trying to drive home is this: is that if Tesla wants to update, okay, maybe the battery system, the software that monitors the battery system of the car. They don't need to come and log into your car to do it. Imagine that Tesla has about more than 2 million cars on the market. How possible is it for them to log into these cars to update them, right? Even if they do is it a callback or a rollback? No, I think it's a callback, right? The letter that you get from the auto dealer, just in case they want to fix something on your car, it's a callback. So if they send a callback letter or asking you to bring your car in, is it a callback or a recall? I think it's a recall though. Yeah, I think it's a recall. I'm just confused with the term that is often used, right? Then what? In that case, you can move your car into the nearest dealer or back to your dealer. That's why you often buy cars in your locality so that you can easily take it there for upgrade, right? So that happens. So all of this what is happening through configuration management. So an example of this is when, for example, your phone provider wants to upgrade your phone. And so they simply tell you, oh, you know what? Please restart your phone. So what? They can prompt the user. Now imagine that Samsung has about more than 2 billion phones that must be upgraded. Okay. So what? It's a recall. Thank you, Brutus. Okay. So why should we implement config management? The first advantage is that it saves time. It takes less time to change the configuration. Yes. Why? Because we are automating inside. With good config management, you know about the state of all pieces of a large and complex infrastructure. Now, imagine you work for a company like PayPal and they send you a laptop. The engineers at PayPal can lock you out. In fact, they can lock out all of their system with one click. So as long as you have a PayPal machine working from home and they have configured it and added it to their list of work from home machines, you can be locked out. So, you could be working for the company in Nigeria and all of a sudden you are locked out of the machine. Sometimes, as I work for HP, sometimes you just sit and you're working and say, oh, you know what? Your system is going to restart in about 5 minutes. And you're like, what? What's happening here? But yeah, okay, the engineers are implementing configuration management. So they don't want to depend on the employee to actually restart the system. They are going to do the config management themselves. That's why a firma was fired from work after he installed Google Meet on a machine. And it was like, what happened? So he installed the Google Meet on Wednesday, and on Friday morning he was fired. Why? They just told him, you know what? You have broken our security protocol. Did not tell him exactly what he has done. But then what? He could remember the last action that he took. So how did they know? Because of course, configuration management, okay, brings what? Okay. Config management guarantees or what gives insight into what is happening in that machine. Now, how many of you know that, for example, if you bought your machine from HP or you bought your machine from Samsung or Lenovo, if that machine is giving you issues, you can call their support. They can fix it right from where they are. How many of you know that? That is part of config management. Being able to, manage servers out of the servers themselves. It's config management. Maintainability is also an advantage. A more maintainable infrastructure is easier to change in a stable way, less configuration drift. It is easier to keep a standard configuration across multitude of hosts. So we can refer to servers as hosts, as computers, as systems. They're all we're talking about the same thing. Oh, my system is down. Your computer is down. Oh, my server is down. I get what I'm saying, like that. Oh wow, the fifth practice is orchestration. This is the core of DevOps in itself, right? And what are we going to use to study orchestration? 5 and 6 covers orchestration. Okay. 5 and 6, Kubernetes and Helm covers orchestration. Okay, is it just covers the automation that supports the processes and workflows. Okay, it also includes provisioning resources. Again, this also covers Terraform. Okay, infrastructure as code. Right, infrastructure as code. So with orchestration, maintaining a complex infrastructure is less like being a builder and more like conducting an orchestra. So instead of going out and creating a piece of infrastructure, the conductor simply signals what needs to be done, and the orchestra performs it. So examples of this orchestra in the technical world will include Kubernetes, see that? Or Kubernetes, it's all the same thing. Okay, some people call it Kubernetes. Kubernetes is all the same thing, right? And Terraform, these are what? These are orchestration tools. So you can tell Terraform, hello, I want to create 100 servers as part of my infrastructure. Say, okay, sir, order received, creating 100 servers. So it's like, is it Siri or Alexa, right? Hey, Alexa, where's Buhari living now? Right, an example. And Alexa will tell you, oh, last time I checked, Buhari was the president of Nigeria. He resigned in 2000, or he left office in, when did Buhari leave office? Last year, right? May 2023. So in about a few months now, Tinubu will be 1 year in office. We thank God. Okay. So instead of going out and creating a piece of infra, the conductor simply signals what needs to be done, and the orchestra performs it, right? The conductor does not need the control to control every attitude. The musician automation are able to perform their piece with only a little bit of guidance. Okay, so here's an example. A customer requests more resource for a web service that's about to see a heavy increase in usage due to Due to a planned marketing effort. Okay, so instead of manually standing up new nodes, operating engineers use an orchestra tool to request 5 more nodes to support the service. A few minutes later, the tool has 5 new nodes that are up and running. Okay, a cooler example is a monitoring tool that detects an increase in load on the service. An orchestration tool responds to this by spinning up additional resources to handle the loads. When the load decreases, again, the tool spins additional resources, okay, back down, freeing what? Freeing them up to the use to what to be used by something else. Now, this is where the cloud becomes so handy in the DevOps process. So this is often handled by tools like autoscalers. Okay. Autoscaling in the cloud is a normal practice. So it's a practice that we implement as part of our DevOps process. You can work for a company and this is all you do, okay? Orchestration. This alone can give you a job as well as a cloud engineer, as an infrastructure engineer, okay? As an infrastructure engineer, and also what? And also as a config engineer. Because Kubernetes is also involved, you can what? You can work as a Kubernetes administrator. So it's going to be so. See, when we get started there, you are going to enjoy because when you understand why we are implementing what we are doing, trust me, you are good to go. So it's like your 5-year-old daughter asks, "Oh, mommy, do we always need to use that oven over there? Why do you always put this in the oven before you serve it? Okay, or what? Why do you always serve the food, or what? Maybe heat the food before you serve." So what the child is asking you, do we actually need an oven? Then what? You're going to explain. Sometimes you explain and explain and explain, you explain tire, no evidence. But in this case, you have evidence. Okay? So, of course, these are some of the advantages of orchestration: stability, scalability, save time, save service, and what? Granular insight into resource usage. So, scalability, okay? The fact that we can build our systems to respond to certain activities. We need an orchestra to perform or to respond. An example is, okay, the festive period just ended, right? You know how busy Amazon is, for example, during that period. Now, the load on the Amazon application, probably in the month of June or July or August, is not the same as what the load on that particular service in the December period. Now, do you think it's going to be feasible for the engineers to fold their hands and say, "Oh no, let's just monitor, if we see more customers, we can just go into the cloud and add more servers manually." Really? So what if all of a sudden we have 5 million customers on the site and the site breaks down? So what we have, 5 million transactions hanging. Do you think the Amazon CEO is going to be happy waiting on you guys to go ahead and add more servers? That may take about 1 hour or 2 hours. What is going to be the effect, the financial impact on that particular process? So what? I'm trying to link it to the business objective. Okay? The Amazon website is supposed to sell products. The company makes its money from the sales of those products. Now it's December period, 5 million people on the site goes down. What happens? What's going to be the impact? Loss of revenue. Okay? Not just loss of revenue during that period. Maybe if I was buying an oven from the Amazon site, I would just search, okay, the next what? The next competitor. Okay, then what? Amazon is going to lose customers. Amazon is going to lose its customers. So when we implement orchestration in an organization, these are the benefits: scalability. We have what it takes to scale our system out and scale it in. So yes, it's December period. We need 10 more servers. Good. The orchestra can add 10 more servers. But it's January 10th. Now things are cooler. Okay. The average load between December 19 to December 31st was 2 million people on the site performing what transactions. That was the average. But now between January 3rd to 10th, we are seeing 100,000. Now, from an infrastructural perspective, do we still need that 10 additional server? No. Then what? The orchestra has what it takes to what? To automatically scale down, because it's possible for us to forget, right? When we forget, things happen. It's again what? Going to cost the company money, right? Because now what? You had forgotten to scale down. So that resource is up and running. And so what? The company is paying for it. When truly speaking, what? It should have been scaled down, brought back to its normal state. So you see that orchestration has a lot of benefit to the business, right? That scalability itself alone, if that system is working, it saves the company's money. Yes, I see more loads. Our memory was, at 100%, but now what is getting down to 40%. At 39%, please spin more servers or add more memory. So this is the system responding automatically. Of course, please note, we will always monitor to make sure that that the orchestra is working. That's what you need, a conductor to make sure. So you are that conductor, and that is why the next practice is monitoring. And now, what are we monitoring? So we have looked at 6 serious practices of DevOps that requires tools to implement the practices. So that we have what? So first we have our orchestra. Infrastructure automation is also what? It's also an orchestra. Configuration management. And all of this is going to happen in the cloud. So we have our chapter 10, over there. Very, very. Now, where are we implementing monitoring? Chapter 7, application performance monitoring and logging, and logging. And logging. I think let's end here for today. We won't have much time, but tomorrow we're going to conclude this introduction, and it's going to serve us. So these are the tools, right? So you see that continuous integration tools. We have Jenkins, we have Travis, Bamboo. Config tools. We have Ansible. Historic already, right? And then tools for virtualization and containerization. We have Docker. Tools for monitoring. We have all of that. All right, and so on and so forth. All right. Anybody has a question before we? Adjolu, thank you so much for joining. I'm going to call you after this call. I know you will try to reach out to us today, which we will try to reach out to you actually, but we're going to have a call. And who else? All right. But so yeah. So that is just what happens, right? So what we are laying this foundation. So tomorrow we're going to what? Start looking at how to set up our Linux environment. So please come. In fact, I think I'll share the video today on how to what? On how to set up what? Your learning environment. Okay? It's very, very important for us to do that. So we are going to have Thursday, Friday, Saturday, and Sunday to set up the environment so that when we come back on Monday, we have that in place. Make sense? We good on that? Okay. All right, everyone. Have a wonderful rest of the day. Yes, Yannick, go ahead.
No. I don't know. I don't have a question. I just want. I just want to say I understand. I'm okay.
Okay, great. Yeah. Okay, so yeah, I'm so glad you understand it, Yannick. Thank you so
Yes.
much. I know that English is it's struggling. You're struggling with English, but it's
Okay.
yeah, but it's okay. Don't worry, you're going to be fine. And
Thank you.
please, when you're in class, if you think that I'm going too fast, let me know. I'll slow down.
Okay.
Okay? Yeah,
Thank you.
always let me know. Yeah. So we can control and make sure that everybody's understanding. Okay. Thank you, everyone. And I'll see you all tomorrow at 5 a.m. Thank you so much. Bye-bye.
Thank you.